Alright folks, welcome back to the next episode of FCI, Physics for You. So today we're going to be talking about none other than question number 4 of the force concept inventory. So that's more of some mechanics and kinematics. Before we do that, our sponsor is Brilliant.org. So if you want to support us, go to Brilliant.org/Barry Science Lab. Okay, so that's going to give you 20% off your subscription. Okay, so let's take a look at number 4. A large truck collides head-on with a small compact car. During the collision, we have to describe the amount of force exerted by the car and the truck on each other. So how do we approach this? So we've got a small car, so got a small car right here. Okay, and we've got a huge truck, right? A huge truck, and they slam into each other. Now the question is, which one exerts more force on each other? Now, the common answer would be, since the car is smaller and it gets more damaged, it would be the car. It would be the big green truck that exerts more force, because it damages the red car more than the red car damages the green car, right? So here is the statement: the green car exerts a greater force on the red car than the red car exerts on the green car. And how do we know that? Well, we know that because the red car is apparently more broken. But as intuitive as that answer may seem, that's the wrong answer. And that physics tells us that's wrong, and specifically Newton's third law tells us that's wrong. Newton's third law, which says what? Which says the force of the car on the truck is equal in magnitude but opposite in direction. That's why we have this minus sign. Opposite in direction to the force of the truck on the car. So actually the force they exert on each other are one and the same. The force exerted by the car on the truck, so force of car on truck, is equal in magnitude but opposite in direction to the force of the truck on the car. Now you might be asking, okay, if the forces are the same, why is the car more damaged? Well, that has to do with the question of mass. The car probably has a much smaller mass than this mega weighted truck over here. That's one thing. It could have to do with the density. So there's a lot of factors, but one of them is not the force. The force exerted on these two vehicles are one and the same. But the car is much smaller, so it gets much more damaged. Not because the bigger truck exerts the bigger force. No, they both exert the same amount of force by Newton's third law. So, going back to number 4, let's see which one of the choices that is. Choice A, the car exerts a greater amount of force on the car than the car exerts on the truck. Well, number 1, that's not even intuitive, because even common sense would tell us that's wrong, right? The truck exerts a greater amount of force on the car. That's what we thought would be true, that the truck is bigger, it damages the car, and thus it would exert a greater amount of force. But we just showed why that's wrong via Newton's third law. The car exerts a greater amount of force on the truck than the truck exerts on the car. Once again, by the same principle, the choice B is just the converse of choice A. So it's equally wrong by Newton's third law. Choice C, neither exerts, okay, this one is interesting. Neither exerts a force on each other. The car gets smashed simply because it gets in the way of the truck. No, well, you have to analyze the situation in the context of force. Of course there is a force. If there was no force, then the cars wouldn't be decelerating, right? I'm assuming these two cars were moving before they hit each other. So if there was no forces, they wouldn't stop. They would not stop. They would continue moving at constant velocity. So that's why choice C doesn't make any sense, because the cars had to stop to get damaged in the first place. How about choice D? The truck exerts a force on the car, but the car does not exert a force on the truck. Again, if object A exerts a force on object B has to respond, right? This is not like one object can ignore the force on it by another object. And what's our final choice? Well, by elimination, that must be the right choice, but let's read it anyway. Choice E says the truck exerts the same amount of force on the car as the car exerts on the truck. And of course, this is supported by Newton's third law, which says that the force by the car on the truck is equal in magnitude but opposite in direction. That's why we have that minus sign, opposite in direction to the force of the truck on the car. And that's why our final choice is none other than E. Alright, ladies and gentlemen, thanks for watching this episode of FCI, and make sure you support Barry Science Lab by clicking on the link at the end of this video, brilliant.org/Barry Science Lab, and that's going to give you 20% off your premium subscription. Alright, so thanks for watching this lecture, and we'll check you out next time.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.